Good morning, ladies and gentlemen. Today is May the 4th on a semi-beautiful Monday. Just in case you can hear that, I've got a co-worker who's insistent on sitting in my lab today. This is Minerva, just in case you didn't know. And she's being very, very cute. But today we're going to be talking about my favorite subject in algebra, or probably one of my favorite subjects in mathematics in general. We're going to be talking about probability. And it's one of my favorite subjects because while it uses the concepts of Algebra 2, and definitely the other mathematics that we use, like Algebra 1 and a little bit of geometry, and it's mostly statistics. And so this is a good branch into my other favorite maths, statistics. But in order to do probability, you need to understand some basic terminology and some basic definitions, along with the basic set of rules that we just understand to be true. I'm going to tilt this down so we can definitely get more cat action in the video. All right, first and foremost, when we see something like this, P parentheses of A, that means the probability of some event A occurring. Now, an event is just something that can exist or can happen, or may not happen. It's just by definition, it's some event. Nope, Minerva, you can't get that flash drive. Now, one thing we definitely need to know how to do is how to convert percents and decimals back and forth. Now, if I have something that's 0.75, in order to move that into a percent, I move that decimal point back 2 places, 1, 2, and that gets me this point, that gives me 75%. Now we can see that also with, like, I don't know, 0.3304. That's the same thing as, okay, girl. We can see that's the same thing as 1, 2, that's the same thing as 30.4%. Now if someone says, oh, you can't have a percent and a decimal at the same time, they're obviously lying to you because we just made a 30.4%. Now, a rule that has to be true about probability, as the probability of any, and I mean anything, has to be between 0 and 1. And that means it has to be between 0%, meaning it can't happen, and 100%, since 1 is just the same thing as 100%. So it has to be between 0 where it can't happen and 100% where it has to happen, or is already happening. And that's for any, and I mean any probability. Let's think of some examples of this. Now, it might be the case for today. It was pretty cloudy today. Let's say that there is a 45% chance of rain. Well, that means the probability of that it's raining is 0.45. Or the event of rain is 0.45. Let's see. Well, this might be an entirely new case for somebody, but let's say you're rolling a die and you want to get a 6. No, let's say you want to get an even number on a 6-sided die. Well, the probability of an even number on a 6-sided die, well, that occurs all 50% of the time, because there's half evens, half odds. Well, obviously that's going to be 0.50. And we can see this, oh, yeah, one thing we might definitely see that there's a lot of ways that a lot of examples that we could bring up for this. But let's move on. I want us for this check for understanding to interpret and write down the meaning of some of these statements. Alright, so take a moment. When I say interpret it, that means, what does this mean? Interpret means, alright, if I were to translate this from whatever this statement is, what would that be in English, or whatever your native language is? Alright, take a few moments, get that down before we get it done. Alright, so probability of A or B. That is the probability of A, the probability of B, minus the one that is A and B. That means this statement means whether I'm having A or B, that's some combination of the probability of the event A happening, the probability of the event B happening, minus the probability that A and B have to happen at the same time. And that's definitely not a multiplication. But we'll talk about this specific case later, because it's one that is fundamentally true when we talk about unions and intersections. But this one, the probability of A, the event A, is equal to 67%. The probability of event A happening, the probability of A happening is 67%. Well, this one says the probability of B is 1 minus the probability of A. Now, what does it mean to have 1 minus? Well, consider this goes off all percents. You can write this in two ways. Well, if I'm using this A from the previous one, well, that's going to be 1 minus 0.67, or 100%, because that's what 1 is. Remember that 100% is equal to 1, or that's 100% minus 67%. Both those should be equal to 33%. So the probability of B equaling 1 minus the probability of A, that's just saying that, hey, I'm going to take 1 and I'm going to subtract 67 from it, 0.67 from it. Oh, and this one is a special case. What was that second rule that we had, or that second bullet point that we had? Probabilities have to be between what? 0, not a 6, a 0. Apologize, my handwriting is horrible today. Between 0 and 1. So this can't even happen. A probability of 1.37 doesn't make sense, because we already say that the probability of 1, or 100%, is our plateau. It is our highest the thing can be. So having anything besides that just simply doesn't make sense. That'd be like saying, alright, the chance of rain, or the chance of foul weather, let's say it's F for foul weather, is this is equal to 137%. There's never going to be a chance of there's never going to be a 137% chance of rain outside. The max it can be is 100%, and that's if it's already raining. So this last one doesn't even make sense. Alright, let's get back to some more basics of probability. Probability is a percentage, we just talked about that, and the percentage is the same thing as a proportion, or roughly the same thing, and it can be written as a fraction. We are going to be using a lot of fractions and decimals in these next sections for this week and next week, so you definitely want to be up to date on all of the ways you can write fractions or decimals, or how to convert them. Alright, but the probability of any event A is E over T, especially when you write it in fractions. Now, E is the number of events that match your condition, and T is the total number of possible events that can happen. Now, what's the probability of rolling an even number on a die? Well, we just talked about that a while ago. How many even numbers are there? Well, if we have a 6-sided die, we know that in the bottom of our fraction there has to be 6, because that's the total number of possible events. Well, how many even numbers are there? 2, 4, 6. So that means there's 3. Probability of an even number is 3/6. Now, whenever you write a fraction, make sure it is a simplified fraction. So 3/6, funny word, 3/6 is the same thing as 1/2. All right, let's talk about the week. What's the probability that when you wake up one day that it's the weekend? What's the probability that you wake up on a random day and it's a Saturday or Sunday? Well, how many days of the week are there? 7, right? How many days of the weekend are there? Well, Saturday and Sunday. Now, you can't simplify this fraction because those are both prime numbers, and so the probability that you wake up on a random day and it's the weekend is 2 out of 7. 2 out of 7. But this should be pretty easy to understand. And if I wanted to, I can convert this to a decimal. 1/2 is the same thing as 0.5. 2/7, I'm a little bit more rusty on that, because you would have to break down 7 into a decimal. I don't particularly want to do that right now. But let's look at this one. Now this check for understanding is a little bit more intense, but let's break this down one by one. Bag contains 12 marbles. 3 of the marbles are blue, 2 red, and the remaining are yellow. What's the probability of reaching into the bag and drawing each one of these conditions? And I'm going to consider each one of these are separate instances. So when you draw a marble, you put it back. So if there's 12 marbles, that's going to be our total, right? So no matter what these are, whether it's a blue marble, a yellow marble, or a marble that isn't red, the base value is always going to be 12 because there's only 12 marbles. Well, if it's a blue marble, how many blue marbles are there? There's 3. So you have 3 because you want one of the blue marble is your condition. So you put how many of those meet the condition. So that's 3 out of 12. That's the same thing as 1 out of 4. A yellow marble. Well, how many yellow marbles are there? It never said. We only have 3. We only have 3 blue, 2 red. Well, do that math. What's 12 minus 3 minus 2? Or the same thing as 12 minus 5. There are 7 yellow marbles. Now, once again, like the weekend problem, you can't break down 7 over 12, so your answer is just 7 over 12. Now this one's a little bit more tricky. It's not asking for red, it's asking for the opposite of red. And that doesn't necessarily mean blue, and it doesn't necessarily mean yellow. It's just asking for a marble that isn't red. Well, if it's not red, it has to be blue or yellow, right? How many blue and how many yellow are there? Well, there's 3 blue, 7 yellow. That has to be 10 out of 12, which simplifies down to 5 out of 6. And so you can express any of these in fractions, and with probability, I'm going to try to write as many fractions as possible because they're more accurate than decimals. But this is going to be a good stop for today with basics. A probability has to be between 0 and 1, and you can express majority probabilities, or you can really express any probability, as a value of some E over T, where E is the number of conditions that you want, how many blue marbles are there, and T is the total number of marbles. Ladies and gentlemen, that's going to be it for today. Hope you guys have yourself a wonderful Monday. May the 4th be with you.